We're going to recap the last few days of notes prior to taking your quiz. So this is just a review. Find the factors of each number and classify as prime or composite. Okay, so factors of 32. We have 1 and 32. 2 goes into 32 as well. So we have 2 and 16. 3 does not go into 32. 4 does, so that's 4 and 8. 5 does not go into 32. 6 does not go into 32. 7 does not go into 32. We already have done 8 and everything above it. So we're done. If it's prime, then the only factors would have been 1 and 32. It has extra, so this number is composite. On number 2, the only factors of 43 are 1 and 43. So this one is prime. For 3 to 5, we're going to find the greatest common factor. So the largest number that goes into 16, you can write the factors of 16 and 24 both down. Or if you just want to write factors of 16, you can see which one of those goes into 24. So you have 1 and 16, 2 and 8. 3 doesn't go into 16. 4 times 4 is, and there's no numbers between 4 and 4. So those are all my factors of 16. And the one that goes into 24, 16 does not. 8 does go into 24. So that is my greatest common factor. Numbers here, 18 and 27. The largest number that goes into 18 is 9. This one has a single B. This one has a single B, so I've got a B in there. This one has an A, but this one doesn't. So 9B is my greatest common factor for that. Okay, for number 5, let's look at the numbers. We have 8, 6, and 12. So we can write down the factors of 6. So you have 1 and 6, 2 and 3. Okay, so 6 goes into 12, 6 goes into 6, 6 does not go into 8. Out of luck on that one. 3 goes into 12, 3 goes into 6, 3 does not go into 8. Got to get rid of that one. 2 goes into 12, 2 goes into 6, 2 goes into 8. So their greatest common factor for numbers is 2. And let's look at the letters. This one has an X. This one has a single X. This one does not have any X's. So X is not a part of the greatest common factor. This one has a Y squared. So I've got 2 Y's multiplied together. This one has 3 Y's multiplied together. So right now they have 2 in common. And this one has 2 Y's multiplied together. So they each have 2 Y's that are multiplied together. This one has an extra one on top of that. But we have to look at what they have in common. So they each have a Y squared. I could write Y cubed as Y squared times Y. So they each do have a Y squared. So that is my greatest common factor. On number 6 through 8, we're going to take out the greatest common factor. And the number part that goes into 4 and 20 is 4. And they each have at least one Y. This one has 1, this one has 2. But they have a Y in common. So I'm going to divide each of those by 4Y. If you want to go ahead and write 4Y plus 20YY and do that middle step, you can. I'm going to divide each of these now. When you factor out a 4Y, you divide each of those by 4Y. And so 4Y divided by 4Y is 1. 20 divided by 4 is 5. So this is plus 5. And one of the Y's cancel, and you're left with 1Y. And you can multiply this out. That'll be 4Y. And 4Y times 5Y is 20Y squared. So it's good to check your answer. You don't have to do the middle step if you don't want to. On the next one, 9 and 33 have a 3 as the largest number they have in common. This has a squared b. This only has one a and one b. So they each have an a and b in common. This just has an extra a. So that's what they have in common. And now I'm going to go ahead and write this as 33AAB plus 9AB. And when you factor the 3AB out, that means you're multiplying it. So I'm going to be dividing by the 3AB on the inside. So I have 3AB. And then 33 divided by 3 is 11. The A's cancel, the B's cancel. Plus, oh, I had an extra A there, didn't I? So that was 11A. On this one, the B's cancel, the A's cancel, and that's left with 3. It's a good idea to check your answer because I didn't notice at first that I hadn't canceled that A out. So I would have not had the correct answer if I had left this A out. But I did realize that I missed it, so I put it back in. Let's go ahead and multiply. So I have 33 a squared b, that's my first term. And then 3ab times 3 is going to be 9ab, which is my second term. So I know I got it correct. On the next one, 10, 40, and 55 have a 5 in common. I think I'm going to work that down here. So they have a 5 in common. This has m squared, this has m squared, this has m squared. They all have an m squared in common. This has an n, this has an n, this has an n squared, but these only had single n, so I can take out one n. This has a p, but this does not, so I can't factor out a p. So that's what I'm going to factor out. I think I'll try and do this one without having to write everything down, but if you want to do that middle step, you can. Okay, so I'm going to divide the 10 by the 5, and I'll get a 2. I'm taking out the m squared, so I'm dividing by m squared, so that cancels. I took out the n, and then I also have a p in there now. So that's my first term. If I multiplied this out, I would get 10 m squared np, which is my first term. Let's look at the second term. I'm going to divide 40 by 5, which gives me 8. I took out the m squared and I took out the n, so I'm just left with a plus 8. If I were to multiply this out, that would be 40 m squared n, so I'm good on that second term. And then on this last one, I'm dividing 55 by 5, which is 11. M squared divided by m squared is 1, those cancel. N squared divided by n leaves me with 1 n still. So I took one of the n's out, I divided one n out. And so if I multiply this, that'll be 55 m squared n squared, which is what that term is. Let's move on to factoring trinomials now. Okay, for the first one, I have a leading coefficient of 1. They have no greatest common factor. It needs to multiply to 9, multiplies to the constant, has a product of 9, and it's going to have a sum or add to the middle term, which is 10. Numbers that multiply to 9, that add to 10, they're either both positive or both negative. Since it adds to 10, they both have to be positive. Our choices are 1 and 9, and the others that multiply to 9 are 3 and 3. However, this is the pair I want because that's the one that adds to 10. And then this will just factor in now to x plus 1 and x plus 9. On the next example, it needs to multiply or have a product of the constant. So multiplies to negative 12, has a sum or adds to negative 4. It multiplies to a negative, so that means one of them is positive, one of them is negative. So you have 1 and negative 12, negative 1, positive 12, 2, negative 6, negative 2, positive 6. There are some other numbers, 3 and 4. So we have 3 and negative 4, and negative 3 and positive 4. Those are everything that multiplies to negative 12. If you can come up with the numbers without writing them down, that's great. You don't have to write them down. The sum, the ones that have a sum or add to negative 4 is this pair here. Once you find the pair, you actually can just stop looking for them. So this is x plus 2 and x minus 6. On the next one, notice the leading coefficient is not 1. However, I can factor out a 3 from all of this. So when I do that, this is going to equal 3y squared, divide that by 3, so minus 3y. And then when I take 120 and I divide by 3, that gives me negative 40. So I'm actually just factoring what's in the parentheses. It needs to have a product or multiply to negative 40, and it needs to have a sum or add to negative 3. And if you can come up with the numbers without writing the pairs, that's great. I noticed that I've got numbers that multiply to 40 are negative 8 and positive 5, so I can come up with those right away. But if you can't, you have to write all your factors that would multiply to negative 40 and add to 3, negative 3. So this is going to be negative 8 and positive 5. That multiplies to negative 40, and that will add to negative 3. If you can't find the pair, you need to write all your factor sets down. And those are my M and N's that I put in here. On the next one, it needs to have a product or multiply to 16. And it needs to have a sum. It needs to add to 18. I'm not thinking of anything that works right now, so let's write everything that multiplies to 16 and adds to 18. They're going to both have to be positive if they multiply to a positive and add to a positive. So you've got 1 and 16. You've got 2 and 8. 3 doesn't go into 16. 4 and 4. Those are all of the pairs that multiply to 16. Unfortunately, none of those add to 18. So this does not factor. This problem is prime. Last example, it needs to have a product or multiply to 6, and it needs to have a sum or add to negative 5. If you can come up with the numbers, that's great. So I know that they either are both positive or both negative. I think I'll go ahead and write them. In this case, they're both going to have to be negative if they multiply to a 6. Okay, that pair adds to negative 7. That pair adds to negative 5. Those are the numbers I fill in. And so we have, in this case, p minus 2 and p minus 3. Make sure you use the correct letter. It looks like on number 10, I used X and I should have used A. So I'm going to go back there and fix that. So that one is X's, that one's A's, that one's Y's, that one is M's, but it didn't factor, and that one's P's. Okay, so I have all of that fixed now. We are done with the notes for today.